Chapter 1.4, Quadratic Equations. We have four methods for solving quadratic equations. Two of the methods only work on select quadratic equations, and two of them will work on any quadratic equation. They're listed below in the order of preference. First of all, we have the square root method. This is the first choice, but it only works on quadratic equations that have one square term and everything else is numerals. For example, if we had a quadratic equation, and we can tell it's quadratic because the biggest exponent is a 2, say x squared equals 4. So I have a square term and everything else are numerals. Hey, I can use the square root method. That simply means take the square root of each side, because when a square root, or take the square root of a square, it undoes each other. And then I'm left with the square root of 4. Now here's one thing we have to remember. Recall, hopefully, from your previous work, that if I put the square root into a problem, I have to say that that answer is going to be a positive or a negative 2. If the square root starts out on the problem, if we just had a square root of 4 listed somewhere, we automatically just consider that the principal or the positive root of 2. But if the problem did not have a radical in it, and I have entered the radical as part of my problem solving, then I have to consider that it could be a positive or a negative 2. Okay, our second method, I'm going to come back and talk a little bit more about the square root method after we talk about factoring. Our second method is factoring. Let's use the example from above. Let's say we had x squared equals 4, and I wanted to use my factoring skills, which, by the way, factoring is a skill set that you must have well developed to be successful in this class, right? We expect that you already know how to factor and that you know how to factor good. So if you do not, perhaps you're in the wrong class, or you definitely need to work on that and catch up. So if I'm factoring, I need it set to 0. I need my equation set to 0. And then this is the difference of squares. So I know I can factor it as x plus 2 times x minus 2. And using the zero product property, that means either x plus 2 is 0 or x minus 2 is 0. Now I have two simple linear equations that I can solve to get x equals 2 and x equals negative 2. Notice I do get the plus or minus 2. So again, just kind of a confirmation that I need to put the plus and minus in there if I have used the square root as part of my problem solving tools. Okay, also, all of our polynomials, which means their exponents are all whole positive numbers, right? Then the highest exponent tells me how many answers to get. So I know I should expect to have 2 solutions to this equation because it's a quadratic. Okay, so back to the square root method. Don't forget that we can also use this on any kind of an equation where I have one total square term and everything else is numerals. So it doesn't have to be just an x squared. I can still take the square root of both sides, which will leave me 4x plus 1 equals, and don't forget square root of 9 is plus or minus 3. So I have my two equations, 4x plus 1 equals 3 and 4x plus 1 equals negative 3, which are simple linear equations that I can then continue to solve. So the square root method, factoring, which we expect you to already be well versed in, and then completing the square. Okay? Completing the square is useful if we can't use the square root method and it won't factor. Okay? We can complete the square to solve any quadratic equation, but if the process makes fractions, we may prefer the quadratic formula. So let's just review our steps for completing the square. All right, so let's take a quadratic equation. X squared, let's say, plus 4x plus 1, plus 1, equals 0. Okay, I can't use the square root method because I have this extra linear term in there. In other words, here's my square term, and everything else is not simply numerals. Okay, I can't factor it because that doesn't factor. So I'm going to try completing the square. First step in completing the square, move the constant to the other side of the equal sign. So in other words, subtract 1 from both sides. Make the leading coefficient 1. In this problem, it already is 1. We'll see one later where it's not 1. Take half of the middle term and square it. So this middle term is 4. Of course, we know half of 4 is 2, but if I'm not sure how to find half of that middle term, if my middle term is a fraction, or if my middle term is an odd number, then half of means multiply. So half of 4, I can just come over and do the math, and then take that number and square it. Okay, this is the number that I want to add to both sides of the equation. Now, factor this perfect square trinomial. I made this a perfect square trinomial that factors in a particular way. So in other words, this is easy to see that it factors as x plus 2 all squared, but even if I had fractions here or difficult numbers to factor, it always factors with this sign and this first number up here, all squared, and then 4 plus 1 is 3. Once I have it in this format, I can use the square root method. So that leaves just x plus 2 equals, don't forget your plus or minus square root of 3. So subtracting 2 from both sides gives me x equals negative 2 plus or minus square root of 3. And there are my two solutions. Negative 2 plus square root of 3 and negative 2 minus square root of 3. Then finally we have the quadratic formula. And the quadratic formula is derived from this completing the square method. Someone realized at some point that if we took a generic quadratic equation, in other words, where the coefficients were just a, b, and c, and performed these steps on them, then here's what our solution is. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm also assuming that you guys already know how to use the quadratic formula, because the problem with the quadratic formula is once we tell you about the quadratic formula, that's all you want to do. You just want to plug every quadratic equation into the quadratic formula. But as mentioned earlier, it really is your last choice. Okay, if it's possible to use the square root method or factoring, that is so much easier than plugging into the quadratic formula. Okay, on completing the square, if in the process of taking half of this middle term or making the leading coefficient 1, you've created fractions, that's an indicator that, hey, this might be a good one for the quadratic formula. Let's do this same equation right here, except using the quadratic formula. Okay, so I'm going to rewrite it over here. With the quadratic formula, just like with factoring, it has to be set equal to 0. And I have to be able, I want it in descending order so that I can pick out my A, B, and C. A is the coefficient of your leading term, B the coefficient of your linear term, and C the constant term. Okay, so then I just plug into the formula. Remember, if there's not a numeral, it's understood to be a 1. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now just simplify. So negative 4 plus or minus the square root of 16 minus 4 all over 2, which is negative 4 plus or minus the square root of 12 all over 2. But it goes without saying, everything always has to be simplified, so I've got to simplify that radicals. So back to the idea from the previous lesson in 1.3 that you already know how to simplify radicals. And 12, now some of us may be able to just write that as 2 square roots of 3. We'll go over again just how we arrive at that. I can change 12 to 4 times 3, and I want to do that because the square root of 4 I can simplify. Okay, it becomes a 2. So I have negative 4 plus or minus, the square root of 4 is 2, square root of 3 stays the square root of 3, all over 2. But now this fraction can be simplified. Be careful about doing something ridiculous and illegal, right? We can only simplify fractions when everything is being multiplied, when I only see factors. So factor a 2 out of the numerator, leaving negative 2 plus or minus square root of 3 all over 2. Now I can divide out the 2's to finally get negative 2 plus or minus square root of 3. Right? Same answer, of course, but much shorter, much more concise. Again, try not to just jump to completing the square. For one thing, on the exam, it's going to ask you specifically, use the square root method, use completing the square, use factoring. If you do not use those methods, you will not get credit for that problem. For another thing, in Chapter 2, I'm going to have to know how to complete the square for some of the kinds of problems we're going to do in Chapter 2, and I'm going to have to complete the square more than once in each problem. So I have to know this method. Okay, so let's look at some examples. All right, after you're told specifically to solve the equations by a particular method on the test, then there will probably also be some that says solve by your method of choice. And so it would be nice if we choose the easiest way to solve them. For example, if this was one of my problems on the exam or on my homework, and I'm not asked to use a specific method, then I'm going to go through the thought process and I'm going to check square root method first. Oh yeah, I've got one square thing and everything else is a numeral. I'm going to use the square root method. Just take the square root of both sides. That way the square and the square root will undo each other, leaving only 4x plus 1. But don't forget, when I add the square root into the problem, I have to make it plus or minus. And then 20, I can change to 4 times 5 because 4, the square root of 4, I can simplify. So that gives me 4x plus 1 equals plus or minus 2. Now the 5 still stays under the radical, so 2 square roots of 5. And now it's just a linear equation I can solve. Have to undo the values being added or subtracted first. So 4x equals negative 1 plus or minus 2 square roots of 5. And divide by 4 to get that x all by itself. So finally, x equals negative 1 plus or minus 2 square roots of 5 all over 4. All right, for the next one, I notice I can't use the square root method. Right, I've got this extra linear term. So I jump down to factoring. Well, hopefully I recognize right away this won't factor, because I would need two numbers that multiply to give 10 and add to give negative 6. Those numbers don't exist. So my next thought is completing the square. This will be a much easier completing the square problem than quadratic formula. First step on completing the square is move the constant to the other side. Then I want to take half of this middle term. So half of 6 is 3, and 3 squared is 9. That's the number I want to add to both sides. The reason I want to add that particular number is it makes this a perfect square trinomial, and I know how it factors automatically. It's going to use this sign and this first value I arrived at, all squared. And then 9 minus 10 is negative 1. Now I can use the square root method, which means take the square root of both sides. So I have x minus 3 equals what? Plus or minus, and I know that square root of negative 1 is I. Now I just have a linear equation to solve. Get that x all by itself. So x equals 3 plus or minus I. Okay. In this next one, we may not want to use completing the square, but we've been instructed to do so. So just so we can see the workings of when the leading coefficient is not 1, let's see how we could complete the square. First step, move the constant to the other side. Second step, make the leading coefficient 1. So that means I've got to divide everything by 2. This right here is perhaps the reason I might choose to move to the quadratic formula. Some of us still might prefer completing the square if we're not too scared of fractions. All right, so this gives us x squared plus 1/2 x equals 6. Now, after the leading coefficient is 1, I'm going to take half of this middle term. Half of a half is 1/4, and square it. That's the number I'm going to add to both sides. Okay, now, this is a perfect square trinomial, and I know how it factors. I made it factor this way. I'm going to use this sign, and this first number we came up with, all squared. Now I'm going to need to add these together, so I'm going to need a common denominator over here. Right? So that would be 96/16 plus 1/16, or x plus 1/4 squared equals 97/16. And once I have it in this form, I can use the square root method. The square and the square root will undo each other, just leaving the x plus 1/4 equals what? Plus or minus square root of 97 over 4. We gotta know how to evaluate these radicals. And I gotta check that 97 and see if it'll simplify. But I believe 97 is prime, so it will not. We'll go back, subtract 1/4 from each side to get the x all by itself. And we wind up with negative 1/4 plus or minus square root of 97/4. We might notice we have a common denominator here, so I can combine that numerator all together over that common denominator of 4. Okay, another quadratic equation. I can't use the square root method. Let's set it equal to 0 to see if we can factor it. In order to factor it, remember it's got to be set to 0. And I'm going to add negative 4x squared to both sides, because when I'm factoring, or really anytime, I want this leading coefficient to be positive, right? So instead of moving these two terms over and then having to change my sign, if I just add 4x squared to both sides, then I get there a lot quicker. All right, so I'd be looking for two numbers that multiply to give 44 and add to give negative 12. So I've got 4 and 11, nope. 2 and 22, nope. 1 and 44, nope. It doesn't factor. I could complete the square. I can complete the square on any quadratic equation. But when I make this leading coefficient 4, I'm going to make a fraction of it 11/4 over here that I may not want to work with. If I don't, then I still have the quadratic formula as an option. Negative b, now pay attention to your notation, right? Plus or minus the square root of b squared. If you just put this, technically that's wrong. Negative 12 squared like this is negative 144. I want to square the whole negative 12. So pay attention to your notation. It is very important that we use the appropriate notation. Just like in English, it's very important that we know how to spell and write grammatically. Okay, so negative b minus 4 times a times c all over 2 times a, which gives us 12 plus or minus the square root of 144 minus, what's 16 times 11? 176 all over 8, which is 12, plus or minus the square root of 32, negative 32, all over 8. Don't forget, very first thing I have to do is take that negative out from under that radical and make it an I. Now, I might want to go ahead, as I'm rewriting that, simplify that 32 to 16 times 2, because the square root of 16 is 4. So I can make this 12 plus or minus 4i square root of 2 over 8. And then I notice they all have a common factor. The 12, 4, and 8 are all divisible by 4. So I can factor a 4 out, leaving 3 plus or minus I square roots of 2 all over 8. Or finally, 3 plus or minus I square roots of 2 all over 2 for my 2 solutions. Okay. One more thing. The discriminant. The discriminant is the part of the quadratic formula under the radical. In other words, b squared minus 4ac. It does not include the square root part. It doesn't include the actual radical sign, only the part underneath the radical. And it tells us what kinds of solutions to expect without actually having to work out the problem. Sometimes that might be enough for us. If the discriminant is a positive perfect square, because it's what's underneath the radical, then if it's a perfect square, I would take the square root, and remember our quadratic equation is plus or minus the square root of b squared minus 4ac all over 2a. So if I plugged in, say, 25 under here, I would have negative b plus 5, negative b minus 5. So I would have 2, right, rational solutions. If it's a positive number but it's not a perfect square, like 27, when we added it all together, we'd be taking the square root of 27, and I'd still get a plus square root of 27 minus square root of 27, but these would be 2 irrational solutions. If, when I calculate the discriminant, it gives me a 0, I would be doing square root of 0, and let's say this is 5, negative 5 plus 0, and negative 5 minus 0. That's the same answer. Technically, there's 2 solutions, right? But they are just the same. So really, there's one, maybe these should say distinct. One distinct rational solution, because there are 2, but these 2 happen to be the same. And then, of course, if we get a negative number underneath the radical, any negative number under there means you have a complex number, and again, you're going to get 2 of them because you would have negative 5 plus your I, negative 5 minus your I. So if this question asked us to just evaluate the discriminant and then determine what kinds of solutions we would expect without actually finding those solutions, first thing we have to do is set it to 0 so that I can determine what my appropriate A, B, and C are. Notice C is positive 1, not negative 1. So do not use the radical when you're evaluating the discriminant. That is not the discriminant. The discriminant is simply b squared, which in this case would be negative 1 squared minus 4 times A times C, or 1 minus 8, negative 7. So there's the discriminant. And then if it asks you to use that discriminant to determine the kinds of solutions this quadratic equation is going to give us, because it's negative, I know that I'm going to have 2 complex solutions. Okay, I think that does it for this section.